Next, we're going to talk about the measures of central tendency, how to talk about the middle, how to talk about the center. I don't need this many air quotes, I think, but there's one more. That last one was bunny ears, not air quotes. So we're going to start by talking about the median, okay? So the median, oh, apparently I'm on a red pen. It's kind of a red pen kind of day. The median value is the middle value, okay? It divides the data into two equal halves. So when there's an odd number of data values, the median's easy. Here's the middle right here. But when there's an even number, that's the middle. So if it's odd, it's not so hard. It's just the middle number. All right, so the median is going to be 12. All right. But if there's an even number, then we're going to have to take the average of both numbers on either side. Because there is no middle number if there's even. There's a blank right there. There's a blank in the very middle of this data. So what we're going to do, remember to take the average of two numbers, you just add them up and divide them by 2. That's going to be 13.5. Okay, so the median for this second data set, for data set B, is 13.5. Okay, and that's how you find medians. All right, and that's one way to calculate the middle. Another one is the mean. I almost couldn't say that word correctly. Another one is the mean. So median is one way, mean is another one. We'll talk about both. We'll talk about when one is better than the other, because all measures of central tendency were not created equal. All right, so the mean is the average, and just like we did the average up here, it's going to be very similar, but now we're averaging a lot of things. So instead of just adding two numbers and dividing by 2, we add up all the numbers and then divide by how many numbers there are. So n right here is how many data points. Nice try, Jason, but not quite. How many data points? And this just means add up. Oops, I don't need quotes for add. I don't need quotes at all, but let's say add up all the values. So add up all the values divided by how many values there are, just like we did right above, right? Whoa, not that far above, right? We added the values and divided by how many values we were averaging of. Maybe not the best example, because here we're only doing 2 when the whole data set was 6. We weren't finding the mean of the data set. We were finding the mean of these two numbers. Maybe not the best example for me to have mentioned, but the idea is the same. Okay, so if we want to find the mean down here, we just say, okay, the mean, and remember, a lot of times we say X bar for the sample mean. We talked about that in Unit 1. And then the population mean is going to be mu. Remember, mu is that thing up there. Okay, so when we're looking at the sample mean right here, that's going to be X bar. That means this big sigma, the Greek capital letter sigma, means add up all the X's and divide by n how many data points there are. So adding up all the X's is 3 plus 8 plus 12 plus 15 plus 18 plus 20. How many data points are there? 1, 2, 3, 4, 5, 6. And then we just type that into a calculator, and we're going to get our answer. Okay? So we go off to the side, type it into a calculator, and we definitely have a calculator ready right now. And we're going to get that 3 plus 8 plus 12 plus 15 plus 18 plus 20 is 76. Divide that by 6 to get our mean. 76 divided by 6 is approximately, so we're not going to use equal sign because we're going to approximate it. So approximately uses these wavy signs, 12.67. Or if you wanted to write, you could write this as 12.6 repeating. You could also write it as 12 2/3 if you want to use a mixed number. All right, so a couple ways of doing that, but that's the mean for data set A. Now this is the same data set. It's a little ironic. It's the same data set as data set B up here, 3, 8, 12, 15, 18. The median up here was 13.5. The average, the mean, is 12.67. So in this case, the mean and the median are pretty similar. 13.5, 12.67. Let's remark on that. Okay, the median was 13.5 right here. Now let's look at a very similar data set. Notice that data set B is almost the same. There's just one little difference. What is that one little difference? This guy. This is probably, no, this is not probably, this is an outlier. Okay? 205 is an outlier. Maybe somebody was trying to write 20 and their finger slipped and they accidentally typed 5. Maybe somebody misread the data, or maybe someone just did really well on this measurement. Who knows? But in this case, it probably is a data entry error. Now let's do the same exact calculations. Just like before, x bar is 3 plus 8 plus 12 plus 15 plus 18 plus now 205, still all divided by 6. We type that into a calculator again, and we're going to get that this is 43. Whoa, that's not how you write numbers. Nice try. 43.5 is the mean now. And again, for reference, what's the median of this data set? The median is still what's in the middle. What's in the middle is right here. It's the average of those two middle values. The median is still 13.5. So notice that even when we have an outlier, the median didn't change. But if we have an outlier, the mean changed a lot, right? So an outlier made the mean really different, but the median wasn't affected at all. That's something that we're going to comment on the next page. Okay? But if you're ever curious about which one is which measure of central tendency is affected more by outliers, think back to this example. All right. So the question is, how do the mean, median, and mode relate to the shape of the distribution? So if it's symmetric, the mean and the median are going to be the same. They're symmetric, then they are the same. If it's perfectly symmetric. If they're only slightly symmetric or like mostly symmetric, then they'll be very close. But if they're perfectly symmetric, they'll be identical. The mean and the median are going to be the same. So let's maybe write same or similar. But if it's skewed left, the mean is going to be less. The mean is going to be to the left. So maybe if it's skewed right, the mean might be somewhere around here. And the median, I'm just eyeballing this. These aren't the actual values. The median might be here. So if it's skewed to the left, the mean is less. The mean is smaller than the median. And similarly, we have, just the reverse here. If it's skewed to the right, the mean might be here, and the median, the median might be back here. Okay? So if it's skewed to the left, we have the same idea, where the mean is more, or to the right, than the median. And the way that you can remember which direction this is, and again, you can, look at the video, look at your notes, is, where are the outliers? And the outliers, if it's skewed to the right or over here. The outliers affect the mean more. Let's do one more example from this to really illustrate it. And again, this really utilizes this important fact right here that we talked about in the previous page. So in this fictional data set talking about box office earnings from Hollywood movies, how does the mean and the median compare? So there's two ways of doing it. One is say, okay, there are outliers here, right? These are really, really far away. There are outliers. So the mean is getting affected by these. The mean is getting bigger because of them, right? The more things on the right, the bigger the mean's going to be. So the mean is going to be bigger. The mean might be much bigger. We don't have to calculate it by hand, though. It just wants us to conceptually answer. That's one way of approaching this, thinking about outliers. Another way of approaching it is say, let's look at this data. Is this data symmetric? Is it symmetric like this? Is it skewed to the right or is it skewed to the left? Well, if we just compare these shapes, right? If we compare the shapes, it's skewed to the right. All right. And since it's skewed to the right, the mean is more than the median. And that's going to be our answer. Again, two ways of getting to the same answer. So the conclusion for this video right here is that we use two different sets of measures, depending on whether we're talking about symmetric distributions or skewed distributions. We've only talked about the center so far, but in the next video, we'll talk about the spread, which is interquartile range and standard deviation. So if it's symmetric, we want to use the mean and the standard deviation because these are affected by outliers. But if it's skewed, we want the median and the IQR because these are not really heavily affected by outliers, or sometimes not affected at all, usually. Okay. This is why we want to use these, because they're not affected by outliers. In general, sometimes they can be a little bit, but in general, they're not going to be affected by outliers. Okay. And that's this video talking about centers, means and medians, how to calculate them.